Hi, this is Chris from DataRobot, and I'm excited to demo two new features which enhance the overtime reporting metrics in DataRobot MLOps 6.3. Prior to 6.3, the overtime metrics reported in MLOps were reflective of the time a prediction occurred. This functionality was perfectly tailored to real-time monitoring of deployed models. There are cases, though, where viewing the metrics on a different time dimension is beneficial. For example, consider the desire to do historical analysis on how a model has performed over time, or cases where large data sets are scored in batch mode, but really represent a length of time such as a month of data. Lastly, time series models often return predictions for a set of dates determined by the model's forecast distance. Viewing the accuracy of these models based on the prediction the date is for, instead of the date the prediction was made, is important. All of these use cases are now covered with the new features in DataRobot 6.3, which allow a user to specify a date in their dataset as the time dimension instead of the time of prediction. For time series, DataRobot defaults to the primary time series date automatically. To demonstrate this feature, I will proceed through our new file-based deployment flow. This flow is ideal for more quickly analyzing historic data to understand your model's performance. Once that's complete, you can decide if you need to replace or retrain the model, or you can immediately implement the monitoring agent to understand this model's performance in real time. Start with adding my training data directly on the deployments page. This data will be used in generating baselines for comparison in my deployment. Additionally, I provide details, a name, a target, and a problem type to help MLOps understand my model. Now it's time to proceed to finalizing the deployment. Here, new in DataRobot 6.3 is the ability to choose the attribute in my file which should be used as the time dimension. And now I'll create my deployment. Once the deployment is created, I'm now given the option to configure a monitoring agent, or new in 6.3, to upload historical prediction data. So I'm going to choose that second option, which takes me back to settings and allows me to upload my historical predictions. Additionally, I'm going to upload a set of actuals that match these predictions so I can get the full functionality of drift and accuracy analysis. Now with this data loaded, I can return to drift and accuracy. The small predictions file I loaded contained New York City service requests that occurred over a 3-day period in early October. I can see these 3 days represented in my overtime plots, instead of a single point, the time which I processed these predictions. Interestingly, if I take a look at my drift, it looks like I should definitely retrain my model. The underlying data has shifted dramatically with the focus on stay-at-home in the year 2020. I am seeing a boost in home-related complaints, such as residential noise and sidewalk conditions, and a drop in commute-related issues like street conditions. I should quickly perform historical analysis on my other models as well to check for similar issues. Thank you for listening.